Welcome back for lesson 30-2, where we're going to be talking about the area of a triangle. So we're going to be solving problems using the area of triangles and composite figures today. So make sure you on your Springboard book, we are starting on page 437. Probably need a pencil and you probably want a calculator for today to help you with some simplifying things. Okay, so we have these pictures of these triangles here, and hopefully you remember that the area of a triangle is 1/2 the base times the height. Okay, now when we're talking about base and height, remember those distances always have to be perpendicular to each other. So in triangle A, your base would be down here. Pen here. Here's my base. Here's my height, because that's where we have our right angle. So if we have a picture like B, okay, our base would be the bottom here, our bottom of our triangle, but the height would actually have to be this distance, our perpendicular bisector here. That bisects this angle into two parts at the top, our vertex angle, but would be perpendicular if we drew it straight down. So just make sure before you compute any problems that when you do the base times the height, the base and the height are always perpendicular to each other. Okay, so let's look at some problems here where we actually find the area on the bottom. Okay, I'm going to have you guys try 3A because this one isn't too bad. But find the area of 3A. So we have a right triangle there. It looks like the base is 5 and the height is 2. So go ahead and find the area of that one for me. Right, if you did it correctly, you should have got 5 feet squared. Now this problem, they're comparing it, they're kind of continuing that the price of the countertops from the previous lesson where they had to charge, like, forget how much it was. Let me look at my book really quick. $8.50 a countertop, so I'm sure that's why they have that 42 there. But all I asked you guys was to find the area. So as long as you could find the area, you should be good. Okay, in B, again, we would have to figure out the height here. So I'd have to draw this perpendicular bisector, okay, from the vertex of the triangle. So my base here is 2, but I don't know the height right now. That's our problem in this particular example. Okay, so when you don't know the height, you can use some things about triangles. Okay, if this is bisected, this is technically broken up into 1 and 1, two little 1 pieces. Okay, and we have a right triangle here. So if we have this, maybe draw it on the side here. We have a right triangle with 1 here, hypotenuse is 4. If we're trying to find our height, x, well, we can do a little Pythagorean theorem to do that, right? So x squared plus 1 squared should be equal to 4 squared. So let's see, x squared, if we have 4 squared, that's 16 minus 1, so that'd be 15. So it looks like our height would be the square root of, not x, square root of 15. Okay, so then to find our area, we'd have to do 1/2 our base times our height. So we actually have 1/2 of 2 would just be 1. So it looks like our area is the square root of 15. Okay, feet squared. So it won't always work out nice. And if we could have reduced that radical, that would be something we would have done. But in this problem, we're technically done here. I'm just going to move this work up here. That's out of our way for the next problem. Okay, but let's look at the next problem. In this problem, we have an equilateral triangle because all of those are the same distance. Okay. So if we're going to find the area of this, again, we can figure out the base. Our base is 6 because that's our bottom, but we have to figure out what the height of this triangle is because we don't know. Remember, the height's always perpendicular. So in order to find the height, let's again call this maybe x, we have to use some information we know about this triangle. Okay. Now, same idea, I can change this to 3 and 3 because we drew a perpendicular bisector. And if that's x, that would be x squared plus 3 squared is equal to 6 squared. So you can use Pythagorean theorem. Or remember, we can use the fact that this would be a, since it's equiangular, would be a 30, 60, 90 triangle. So remember, if your short leg is 6, your hypotenuse then should be this root 3 root 3. Which is the same thing we would get here if we solve for the Pythagorean theorem here. Okay, it'd be the same thing if you simplified that. 36 minus 9 would be 27 and reduce the radical. So a couple ways to find the height there. Again, you could use Pythagorean theorem with the right triangle, or using the properties from a 30, 60, 90 triangle to find that height. Either way works. So now that we know our height and our base, I can find the area. So area is 1/2 our base times our height, which was 3 root 3. Well, half of 6 is 3. 3 times 3 root 3. Now, remember some radical properties. You can only multiply whole numbers times whole numbers, radicals times radicals. So this becomes 3 times 3, which is 9. We didn't have any other radicals in our multiplication, so that root 3 is not going to change. So that'd be 9 root 3 feet squared. Okay. So if you have to find the height, it does make the area problem a little trickier because you kind of have to use little properties. But again, you can always use Pythagorean theorem or some triangle properties from before. But actually, we have a special formula that we can use for equilateral triangles, and I'll talk about what that formula is right here. Okay. So if you have an equilateral triangle, meaning all sides are the same, all angles are the same. Okay, it has a special formula, and I'm just going to show it to you guys instead of deriving it, just so we can use it together. But it's the square root of 3 over 4 times your side squared. Okay, so whatever your side length is. So it says to use the formula to solve for that same problem before where we had the 6's on all sides. So if we do that, I'm just going to plug it in really quick. We have the root 3 over 4 times our side, which was 6 squared. So that's root 3 over 4 times 36, right? 6 squared. So you can see if I put this over 1, we can kind of do some cross simplifying. 4 goes into 36 9 times. You're left with 9 root 3. Okay. So this is just the second way to do that. And again, it only works for equilateral triangles. If you have an equilateral triangle, you can use this formula. It's a little faster than what I did on the previous slide here, where I had to use Pythagorean theorem or 30, 60, 90 triangles. Okay. If you just know the side lengths of your equilateral triangle, you can use that formula. Okay. All right. We just have one more triangle to look at, and it's on the next page here. Okay, so we're not going to really do too much with the proof here. They say complete the proof to discover the formula. We're kind of just, I'm going to talk you through it. But if we know different side lengths, if you remember this picture, it's kind of the same from our law of sines, law of cosines rules from the last unit. Okay, but we have a triangle here, and this is a formula you're going to be using if you know two of the sides and an included angle. Okay, so you see how they kind of are marking angle A here. So the way we could find this formula is we would start with the area formula, which is 1/2 base times height. It says draw and label a perpendicular line H from point B to AC. So let me do that. I'm going to draw a perpendicular line from point B to AC. That's perpendicular. They say call it H. Okay, they want you to find the sine of A. So remember, sine was opposite over hypotenuse. So here's angle A here, and we're kind of just using this triangle, that right triangle. So the opposite side of angle A here then would be H, the one line I just drew in, over the hypotenuse C. Remember, the hypotenuse is always directly across from your right angle. So then if I have to solve for H for that then, okay, I would just have to multiply both sides by C. So this becomes C sine of A would get H by itself. Okay. Now, if we plug that back in for 1/2 base times height, if we plug in this expression for the H, okay, it'll simplify to our formula, which is essentially this. Okay, so it's 1/2 our base times C, okay, sine of A. Okay. So let's look at a picture here. So I'm going to do an example with you using this formula, and then you guys will try one on your own, and then we're done. Okay, so again, this is a formula if you're given an angle. Okay, one of the angles, the included angle, and that's important to know, it's your included angle. So we're going to be using these two. So this is, again, little b, because it's across from the b. This would be little c, because it's across from the c. It really doesn't matter, though, what's b and what's c, though, because you're just going to be multiplying them together. But just know the angle they're using must be the included angle for your two sides. All right, so if I plug this into my formula, we have 1/2 our two sides. In this case, it's 5 times 7, okay, times the sine of our angle, our included angle. So the sine of 49. Okay. So let's see, we don't have any even numbers here, so it's not going to work out too nice, but we have 35, okay, half of that times the sine of 49. So the rest of this we're going to need a calculator for. Okay, so let's pull up our calculator. Make sure your mode, okay, of your calculator is in degree mode. So check that. Make sure degree is highlighted before you do anything with the sign. But let's say 35 over 2, 17.5. We times that by our sine. So the sine of it was 49 degrees. Should give us our answer. So it looks like 13.2. And did they give us? Yes, feet. So feet squared is our area here. Okay. So again, we only use this formula if we don't know. So like we didn't know the height in this formula. All we knew is two sides and an included angle. Okay, so this is for when you don't really have a nice right triangle to find the height for. You can use this formula for it. Okay, so let's have you guys try this problem 11. Okay, find the area of a triangle if the measure of angle C, so C is 10. Okay, B is 24, so this side is 24. Okay, and the measure of angle A is 38. Okay, so you have your length B. Okay, you have your angle. Go ahead and find the area of that. So you have your included angle in your two sides. So use the formula. I copied it back up on the top here in case you need it. So go ahead and find that measurement there. Okay, if you did it correctly, according to your book, you should have got the answer of 73.9 meters squared. Okay, so we did, I know we already know the basic formula for area, the 1/2 base times height. So this lesson was just kind of going over two new formulas you're going to have. So the formula for an equilateral triangle, square root of 3/4 times side squared. And the formula for our triangle when we are given an included angle in two sides. Okay, so we'll practice this in class tomorrow, all of our area formulas, but we're kind of adding on to more and more shapes here. So the next shapes will be your next video.